we're going to talk about policies, and I thought the best way to talk about policies is perhaps, do it using the demo rather than just talk through this. So here's the first use case. I'm going to talk about that, and then I'm going to switch to the demo. But let's talk about the demo, right? So the first use case, so what we're going to show is that pods within a namespace can talk to each other, right? So, and this is sort of what we call like our developer workflow. And the reason we've done this is that it really simplifies things, right? So if you want to, you as a developer, actually you have to do nothing, like absolutely nothing for networking to come up, but we still do some things behind the scene. But what we do is when a namespace in Kubernetes is just a way to scope things, right? So for example, it could map to an application. Some people want to map microservice to a namespace. So whatever you choose, it's something you choose. But the idea is you have to do absolutely nothing. So what we do is we monitor. We have like I said, we have a policy plugin on the master. So it monitors the creation of these namespaces, and it immediately creates a subnet for that app. It knows an app is going to get created soon. So I'm going to go ahead and create a subnet for you, right? Then it also what it does is it automatically sets up some ACLs. So for example, there's like a default namespace where you run some sort of core services, or could be running, for example, the Docker registry. So we automatically create ACLs so that when a pod comes up, it needs to, or when you're spinning up the pods, they need to pull the images. So we set up the ACL so that that namespace for that app can reach to that default namespace. Then, within Kubernetes, I talked about services. So we also automatically create ACLs so that, when pods need to reach out to a service, the ACLs are already in place. So like I said, the developer has to do nothing in this scenario. They just have to come up, and they will get automatically, they will get IP. You still get the IP per pod and all of that. But behind the scenes, we're doing a lot of the heavy lifting. Now, the second use case I'm going to show is kind of builds on use case one. And what we're going to do is simply spin up another application called Guestbook, right? And again, it will be with the developer workflow. But what we'll do is that we'll show that pods from one namespace cannot talk to another namespace. And again, the developers had to do nothing. The admin had to do nothing either, right? So no one actually had to do anything. Out of the box, you get this. So let me sit down and show you guys this demo. Okay, so let me show you guys again. We have something similar to what Hari was showing you guys. Let me hide this. Okay, so as before, we're going to look, again at our VSD, which is our graphical user interface for the system. So as you see, there are some default, things in place. The default namespace and the cube system. These are, always there. And then we've created something called TFD, or Tech Field A, and this is going to be used in the next demo. So at this point, as you can see, there are some there are no vports actually in this default namespace. The cube system has some vports which are running some system services, right? And you can see actually we show you that we differentiate between containers and VMs. I think Hari also kind of went through that, but I just wanted to point it out that we'll show you when we have VMs, and we'll show you when you have containers. And then the TFD namespace is empty. Now, in our case, what a namespace is really mapping to is one or more subnets. So right at this point, really what I'm showing you is a subnet. So now let's jump over and run through those demo scenarios. So what I've got is I've got a script to kind of help things around. So all I'm going to do first is just make sure we've got cluster which is up and ready. We've got 9 nodes at this point, and we're going to see if we have any pods. And at this point, we don't have any. So now what I'm doing is really I'm spinning up 3 instances of Nginx, and they're just going to come up with no policies or really in place, but just getting created. And really, the developer had to do nothing as far as networking is concerned. So at this point, the 3 instances are up. Now, if I go to the VSD, right, you can see that these are my 3 containers, right? It shows I've got Nginx, tells me what the hypervisor IP is and all that, right? Now, so let me make sure that I talked earlier that we automatically create some policies, though, because you need some policies to be able to get service IPs, right? Because what you're going to do is the way you typically consume services is not by direct pod-to-pod communication, but a pod is going to reach out to a service IP of some sort. So at this point, I've created a service, I've exposed a service, and I'm good to go. So what I want to do now is see, okay, so this is really the 10.254.107.186 is a service IP. So I'm going to try to reach from one pod to the service, right? I'm not going to do, because that's the way you would write your applications, right? So what I did is simply I did a curl from one of the pods here, and I reached out to the service IP, right? And as you can see, the response came back from Nginx, the standard response. So it means that without doing anything again, the developer didn't have to do anything, but networking is all set up for the developer. Now let's make sure if they want some people want to write their apps differently and say, okay, I really want to have pod-to-pod communication directly. So can I do that, right? So again, we're going to, in this case, go from one pod to another pod. So in this case, I'm not using the service IP. You can see the 70.70 is really an IP from the pod. And again, I get the same response. I didn't really have to do anything different. It was all set up to go. So that was use case 1. So now let's go ahead and deploy the second app, like I said earlier. So guestbook app is another standard sort of Kubernetes example app that I'm going to set up. And in this case, there are going to be some Nginx pods. There's going to be a Redis master and a couple of Redis slaves, right? And again, I've spun them up. They're getting created at this point. It takes a little time to pull the images, actually. And now we can see, OK, everyone's up and running. Yeah, I'm going to go. So now you can see that up here we had the pods from the first application, right? These were the 3 Nginx pods. And here, I think I should see like 6 pods, 3 Nginx, and 3 Redis pods, right? So again, the developer had to do nothing, right? But now if I go back and say, okay, let's see if I can reach from one. So at this point, I connected to the I created the second app, which is the guestbook app, and then now I'm going to see if can I try to go from the first app, which was in the default namespace, to the second app, which is the guestbook in the guestbook namespace. So I'm picking a container from my first namespace and trying to connect to the service from the guestbook. And as you can see, it's going to time out because the way we have set up things, the apps are absolutely isolated. There's no way, unless a policy is in place, for them to connect to or talk to each other.
Can you speak to how granular that is? So I noticed that you're showing these pods, right?
Yeah.
Are you doing policy between groups of pods, or are you just saying, the service is good enough and you're enforcing policy simply between services?
So we can do both.
Yeah.
And the next demo is going to be that exact thing that you're talking about. Because, so this is, to demonstrate that, hey, and now, so let me just walk through this part, right? Finish up with this demo where, okay, now I'm going to say, okay, maybe to come back to kind of your point is like, only are you doing policies between pods and services? So this one, I'm going to try to go from one pod to another pod directly so that, hey, are there other holes in our system, right? And so I'm going from one pod directly to another pod. And we did this earlier within the default namespace, and we saw that that was working. But now you're going to see it's actually not working, right? So this is timed out, right? So I'm going to just quickly clean up. And what we'll see also is when we go to the VSD, everything we've created is going to go away. And that's really, the idea was that, simple things should be simple, but complex things should be possible, right? That's the philosophy we've taken. Right, that's quoting Alan Kane. It's not my quote, but that was the idea. Is that if the less the developers have to do, but at the same time, if you want to come in with advanced policies, then we're going to see an example of that. So just let me clean up so there's no noise when we do this. Okay, perfect. So I'm going to go take a look at the VSD, right? Sometimes it takes a little bit while for the GUI to catch up, but there's no, so this was where we had the default application, right? And then as you can see, the guest book, everything was cleaned up because it was an auto developer workflow where we create subnets on demand and then we tear them down. The other thing I want to point out is we start out with a small subnet, or it depends on what you want it to be. So if you don't want to exhaust your IP address space very, very quickly, right? You spin up 100 apps, bring them, and then the 101th app can come up. So we make sure that we can scale so that you can have applications of different size, and you're not like giving every app the same space. Okay.
Some of the vendors are using Tosca as a model for service chaining of the virtual machines. Are you using Tosca or are you using something else?
So within VSP, yeah, I mean, we're not really using Tosca, but Tosca is probably something that sits also a layer above us. And there are, we have other products like Cloudband, etc., which are looking into that. So we don't actually use.
You're at the lower layer.
Correct.
And then, provided, of course, that things like subnets, as you mentioned, as well as ports are allocated dynamically, the developer doesn't have to be concerned with those whatsoever. What then are you using to map pods and services to policies within the Nuage solution? What is that link, basically? How do I know that I need to apply the web to app policy to this pod based on some labels or something like that? I assume it's labels.
Exactly.
Yeah.
So yes, we are using labels. So let me now jump back to the next use case, right, which is the final use case, which I think is a more interesting one as well, because this is where when you go to real deployments, this is what the ops team wants, right? This is what they've come back and said. We want the flexibility, right, of being able to impose the policy that we want to impose. So let me walk you guys through the workflow for network policies, because I think this is very interesting. So this workflow is a little bit different because obviously you're now getting into more advanced policies. So you need to set up policies, and the way you do it is you first go and provision those policies on our policy engine. And so you can use our SDKs, you can use our REST APIs, whatever you're comfortable with. And then when you're creating your pods, the way to specify the policies is to use labels, right? Kubernetes has labels. Some of you may or may not be familiar with it. So labels are nothing but just key value pairs, as you have find in multiple other systems. And so using those labels, you specify, okay, I want this pod to be part of this policy group, right? And then that's how you set up those policies. Now, So we have this concept of policy groups, so you can place your pods in policy groups. Or now when you're doing but like I said earlier, typically you are not really talking to pods directly. You're going through the service IP. So then we also allow you to create pod to service IP. We have something called network macros. So you can set up I want policy from this policy group to that service macro. There are other things we have as well where, let's say, so the previous use case that I showed was that inter-namespace communication is not allowed by default, but then we have users like, I want to allow it selectively because I have some shared services and I want to make sure I can open up that communication, but it shouldn't be an all or nothing, right? It shouldn't be that no one can talk to each other or everyone can talk to each other. So we have this thing of what we call a zone-to-zone policy. So I can go from one namespace to another namespace. So it's a very powerful policy model. So it doesn't force you to kind of, no, everything has to be a policy group or, no, it's only based on IPs. So there's different things you can do. So coming back to this, right? So we are using labels to pass in that policy information. And then when the pod is being created, then we look at the metadata, the labels that have come in. And then we, go back to our controller, which talks to our policy engine, and it gets the policies, downloads them, and then those are installed within the VRS. And at that point, when the pod comes into life, it's ready to go. All the policies have been downloaded, and you have to, not worry that, hey, are the policies going to be in place? So this next demo is interesting. I'm going to talk about this use case because we've been talking about, okay, we can connect different environments. So this is kind of designed to simulate that. So I'm going to have sort of an app. It's going to be spun up in the demo namespace. I'm just going to have 2 Nginx pods. Now one of the Nginx pods we're going to put into a policy group. And the other one is not going to be in a policy group. And what I'm trying to simulate here is I've got a service running somewhere else, and I want to be able to allow some pods to access those services, but not all the pods in my app, right? So my front-end pod should not be able to get to those, those services, but the back-end needs to maybe talk to a billing server or needs to talk to, like a customer database. So this is going to selectively allow pods from within one app to talk to that service. Now the way we are simulating the service today is we're going to create a namespace. It's still going to be a namespace with pods, but what we are going to do is we are going to create a service IP for that. So now these 2 are in different namespaces really, right? And then what the policy is going to be is it's going to be a policy from a policy group to a service IP, right? I talked about our network macros. That's the way you do these things. And you can do some interesting things. Let's say you have 2 services. Now you don't have to create 2 different ACLs actually. You can create a network macro group with those 2 service IPs or those 2 service CIDRs. And that way we've got very, very efficient ACLs going on, right? Hari's talked about the ACL explosion problem, and we are doing our best to minimize them, to really not have more than a couple or less than 10 policies per complex app. So those are some of the mechanisms we have to reduce that complexity. So now let me go back. So what I've done here is we've got this little script which is going to go, and it's a Python script. It goes and sets up the policies that I need, right? So let me see if the VSD is up. Well, it was always up. I just had to get to it. Now let's look at our topology here, right? So here we are. There are no containers right now. So what I'm going to do first is I'm going to show the labels that you were mentioning, Matt. So take a look here. I've already created those policies, and now what I'm doing is I'm saying, okay, put it into this subnet and this zone, right? And And then these are actually going to be my containers representing that service CIDR that I showed on the right side. Right, so these pods are not deployed, and we can see them. They're going to be coming up. They're not. There's 3 of them. They're coming up. Okay, so they're up. Now, the next thing I'm going to do is create the 2 Nginx pods, which are in the demo app, right? And here, what I'm going to do is going to create them differently. One of them has policy. So as you can see here, we've policy group label that we are using, right? So I'm going to put it in the policy group demo, and then I'm going to create another pod which does not have that policy label, but they're still within the same app. Okay, so both of these are should be up or coming up, right? So these are the demo pods. One of them has a policy. Let me go show you. There is a policy here. So one of them will show that I have a policy. So you can see this one has a policy, whereas this one has no policy attached. And what that policy is allowing me to do is go from one policy group to a service CIDR. So now, that's the first one is going to be with policy. So I've got a policy in place, which means I can access that service. And now I'm going to go from the other one, and now this one is not in the policy group. There's no policies in place, so it's going to time out because it has no way to get out and talk to that service, which means your app developer, as a infrastructure operator, you can be assured that you have the granular control that you're looking for with all policies in place. So as you can see, it timed out, right? And again, we were able to show the granularity with which you can do things. Now I'm going to quickly wrap up, just kind of summarize what we bring to the table here. So in conclusion, what you saw today that with VSP and Kubernetes, what you're getting is we're providing you with a multi-tenanted solution, right, with app isolation within a single tenant. We give you full control over IP addressing, and given our platform's richness, we're able to support hybrid environments which connect VMs, containers, and bare metal servers together. And we can deploy our solution on-prem or in public cloud. And then finally, I think most important probably, is our very granular, very flexible security policy.